Hi, team. Thanks for showing up for your learning. One of the most tricky but also interesting topics in 11 functions is the case of the ambiguous sign law. All right, so these are questions, they might look like this, where if I tell you that triangle ABC has side lengths B equals 20 and A equals 12. All right, so and then angle A is 30 degrees. And then I tell you some extra information, like maybe angle B is obtuse, or maybe you don't have that information and you're asked how many triangles are possible. And students will think, well, what do you mean how many triangles are possible? I know like two sides and an angle. Shouldn't there only be one triangle available? And sometimes no. And I'll walk you through this today. So, this topic actually is going to give us a great opportunity to take the confusion that it can build and connect it to trigonometric functions to better understand trigonometric functions. That's the end of this week's topic. As well, this is going to boost your understanding of angles and standard position and the way even that your calculator works. Okay, so let's first start over here and we're going to create as good a diagram as we can. So let's start with angle A, and I like to put angle A over here, and it's 30 degrees. So let's draw that. Pion and pion, like that. So that's about 30 degrees. All right. And then we always name these triangles this way, where if this is side A, then this is, sorry, that's little side A, then this is big angle A. And if this is big angle B, then this is little angle B. And this is big side C, big angle C, then this is little side C. Okay, they're always named opposite the side and the angle. So let's put angle B down here. We know angle B is obtuse, okay, and that side B is 20. And so that would mean side A is 12 over there. And we don't need such a long line for that line there. This would do fine. Okay. So this is the triangle that we're expecting. And we want to find the measure of angle B. We want to find the measure of angle C. And we want to find side length C. Okay, so here's how you would set this up. Of course, this is how you would set this up. Let's first solve for the unknown angle B. Okay, we're going to set this up to solve for unknown angle B. So you would say sine of A divided by the side length of A is equal to the sine of B divided by the side length of B. And then you would proudly get out your inverse operations pen and multiply both sides by B to cancel that, right? And then this is what you're going to get. Okay, B sine A over A is equal to sine B. Okay, so this is what we're looking to solve. We know we're trying to find sine B, and that's equal to this expression here, right? So let's write it out. B sine A over A, and you just copied a bunch of stuff that you'd already written down, Mr. Jennings. Well, yeah, fine, all right. So I'm going to substitute in for those things that I know. So side B is 20. Sine of the angle, well, the angle is 30. That's angle A. And side A is 12. All right, so let's go. That will give us, and then we get out our handy dandy calculator and do some calculations. And the calculator never lies, right? The calculator never tells us anything that's confusing, right? So I'm just going to do 12 divided by 20, so that's 1.6. I'm going to multiply that by 30, but I take the sine of it. Oh, it turns out sine 30 is 1/2. And if you've done that lesson, then you knew that. All right. And then so this is sine B is 0.83 repeating. All right, so 0.83, 0.833 for more accuracy, 0.8333, or this is perfectly accurate, so this is sine B. And then what we're going to do is we're going to probably do this on our calculator, right? B is therefore equal to sine inverse of 0.83 repeating. So let's do that. Sine inverse. Oh, tells me it's 56.4 degrees. So B is equal to 56.4 degrees. You see where students get confused? They're like, wait, but B over here, we want it to be obtuse. We don't want it to be, we don't want it to be acute. That would be less than 90 degrees, but we've clearly drawn this with it being more than 90 degrees. Why is we getting this? Why is we getting this confusion? Well, let's take a look. Here, I've diagrammed it for us here. Okay, here is the side B. You see, I set that at 12. That's this line here. So that's how long that is. So we have that at 12. This is 30 degrees over here, so that's no problem. That's about 30 degrees. And this one, this side, is actually 20 long. Okay, so this matches our diagram perfectly. And I can change this angle here, and I can see, okay, this side could make a triangle there. And then, oh, look, it's like 53 degrees. And what did we find? 56.4. So let's set it there, see if that looks like a triangle. 56, there. See, that's a triangle, all right? That's one of the triangles that we can be making here, okay? But what if I want it to be a triangle on this side? You see, it can make two triangles because of the nature of the diagram, right? Because B is long enough to touch on two spots, it could be two different triangles. Okay, cool, right? Okay, so why are we getting this ambiguity, and how do we find this angle like 125 or 127, or maybe it's 126 or so, something like that. 120, 120, 126 it should be. Anyway, like why? Why are we getting that? And how do we figure these out? Okay, well, let's also take a look at this graph. Now this graph, I wanted to show it to you. This is a graph of sine x as though it's a function. And there's a few things that you need to change to be able to see this nicely. Go into the graph settings, move any useless faces, go into the graph settings and change it to degrees. You always want to do that with your calculator. We only really care about the domain of sine, sorry, the range of sine, the different y values is between 1 and -1. So let's just look sort of between 1 and -1. I'll put it like 1.5 just so we see a little bit more. But x, I mean, we can go full 360, right? So we want to see at least 360 degrees. So let's bump that to 400, and that's good. Now we've got a good picture of what sine looks like. Okay, so here are the values of sine for different angles. And if I go up to 90 degrees, you see sine is 1. And if I go to 180 degrees, sine is 0. And at 270 degrees, sine is -1. And at 360, it's 0. And 0 degrees, it's 0. Okay? And what we were asking our calculator to do here at this stage was we were using the inverse function, which is sine inverse. Okay? And we were saying, I'm giving you an output of the sine function. I want you to tell me the input. Okay, see, inverses, they're very useful because they help us algebraically in these types of cases. So what we were doing was basically saying, okay, I know that I want to know where this has a y value equal to 0.8333333333333. Let's put in a lot of threes for accuracy. Okay, there. All right, so I wanted to know either that angle, 56.4, or that angle. You see how there's two possible solutions? Just like if it was a parabola and a line cutting it, there can be as many as two solutions. Well, here there's actually an infinite number of solutions. You see, it keeps on intersecting as we go around and around and around and around and around the circle. Okay, so the one that we want is actually that one. Okay, but how are we going to find that if we don't have access to Desmos and we want to work algebraically? Okay, 123.5, so that's 124. And indeed, when we look over here, when I set this to 124, that's a triangle. This is a triangle over here, and that's the triangle we're looking for. Okay, so that's how that works. All right, so now, how do we find that? Well, okay, it's also related to this idea over here. Okay, if I set this at 55, 54, which was the first one we found, right? Or 56, was it? I forget. It was 56 or 54. Oh, it was 56.4. Okay, so here, this is the unit circle, and you will encounter this in your travels as well. Notice when this angle down here, when I set that to 56.4 or 57, whatever, that up here it gives me the height of that point, which is sine, is 0.839. Okay, 0.83333. But if I take that and I go all the way over to 124, he says, trying to get the right pixel there. The sign is the same because the y value is the same. You can go around the circle and it's the same. This angle down here will now be 56 degrees. So we can use this idea of related acute angles to find the value of the other angle that we're missing. All right, so let's go ahead and do that. We're going to go back here. We've got 56.4, but I want the obtuse angle. I could, if I want, zoom in here and draw the other triangle. Right? Actually, I'm going to do this diagrammed down here. So here is my side 20. Here is my side, I don't know how long it is yet. And then if I drop this side down here 12, and this is 30 degrees, what we just found is this is 54.6 degrees. 56, I keep on saying 50. It's 56.4, that's why I get confused. 56 degrees, okay? But it could also be over here, where this would be 56 degrees, okay? So if that's 56 and that's 56, why? Why do I know that's an isosceles triangle? Because this would be 12 if I flipped it over there as well. So the two sides are the same, so the two angles will be the same. So this angle here, call it, I don't know what it is, call it x. Well, it's already a little angle b. But angle x is equal to 180 degrees, 180 degrees, because that's a straight line, minus 56. And that's how you find it there. Okay. You can also think, and so that's like algebraically connected to this like geometric idea. Why here we can use the related acute angle and do 180 degrees minus 56. Okay. That is here on the unit circle. If we go 180 degrees and then we go minus 56 degrees, that's our related acute angle, we will find the desired angle here, which is angle B, or I called it X there for some reason. Okay, so now we know angle X, or now we know angle B, sorry. So we can say angle B is this, or B equals 180 minus 56.4. And so that gives us beta is equal to 124.6. See how I get confused there? Which 124? 123.6. 123.6. We're going to round to 124. We're going to round this. Okay, so there's our obtuse angle B. So now we can go ahead and put that on the diagram, 124. Now we can go ahead and find angle C. Angle C will be easy to find now because we have C plus A plus B, all the angles of a triangle add up to 180. And let's put in for the ones we know, C plus 30 plus 124 is equal to 180. So that's 154 total. When we subtract 154 from both sides, we'll get angle C. So that's C equals 26 degrees. So this is 26 degrees. And now we can use sine law to find that side. So let's do that. So I'm just going to bring my diagram down here because my algebra has spiderwebbed all over the place. And yeah, it's a thing that can happen. This is 30 degrees. This is 24 degrees. Just want to make sure it's not 26 because I've been flipping my, it is 26. I've been flipping my 6s and my 4s this whole video. This happens when I talk and I'm doing math, is that I start fudging numbers. Okay, 26. and this is 124. That does it. That's where the 4 goes. All right. So now this one was 20. This was 12. And let's find out how long little side c is. So now we'll set up sine law upside down. C over sine c is equal to, let's go with a over sine a. Substitute in what's known. We can even multiply by sine c here to multiply both sides. And so c is equal to 12, because that's side A, multiplied by sine 26 divided by sine 30. Okay, there, punch that on your calculator. 12 times 26, but I take the sine of it, and then I divide by 30, but I take the sine of it. Okay, so that side is 10.5. Now let's go ahead and check and see if that looks about right based on this Desmos triangle. So does that look like about 10, a little bit more than 10? Sure does. Let's go up. This goes from just a little bit before 7 to a little bit after 7. So it's 10 and a bit. Great, we found the answer we were looking for. But the cool thing here is, first of all, it's really weird. You can get two different triangles, and the reason you get two different triangles is because of the algebraic ambiguity of that answer, right? Your calculator is giving you one possible answer, but there's another possible answer. We can see that when you have the really good idea about the unit circle, that the sine there, see the y value here of this point is just the value of sine of this angle. It can be the same there as it is over here, right? The value of sine is the same, 0.83, and then over there, 0.83. See, same value of sine. Okay, and that's also connected to this idea that we can have that horizontal line intersecting the function at multiple points. So this sine function has some ambiguity between the value 180 and 0. Okay, I hope that helps put together some of these ideas and gets you ready for trig functions. Notice that when I'm working in Desmos on these trig functions, I need to change my scale and I need to change it into degrees. Otherwise, any questions, hit me up by email. Bye for now, everyone.